Hi everybody. So this is lectures on AI, history and future. But of course, critical AI literacy, embracing AI for social good. Intelligence. What do we mean by intelligence? Let's start with some IQ tests. If I ask you, how will you distribute 8 mangoes among 6 people? You probably have a lot of interesting ideas. So I asked same questions to ChatGPT to distribute 8 mangoes among 6 people, and ChatGPT say you could give each person a mango and then give the remaining 2 mangoes to 2 random people and perhaps split them between all 6 people. Okay, right? Not too bad. Alternatively, you can cut the mangoes into smaller pieces and distribute the pieces equally among all 6 people. Also okay. Okay, so we say maybe ChatGPT have some intelligence. So let's move on, try another questions. Okay, you see this is a very typical IQ test as well, right, for primary school students. You see the patterns, okay? You have 2 rows. One is the upper row and the lower one, bottom one. Okay? So blue followed by red, orange followed by yellow, green followed by red, blue followed by yellow. What should be next patterns? I provide you 4 options, A, B, C, or D. Okay? So I've input these questions into the ChatGPT, like what you see in the slide. Okay? So and ask ChatGPT what should be the color at the top, what should be the color at the bottom. If you follow the patterns, that's how I understand these questions. Okay, on the upper row, start with blue color, then orange, then green, then blue, and maybe the next color should be orange. How about the bottom one? Red, yellow, maybe red. Okay, so that's why I'll consider option C to be the correct answer. How about the answer from ChatGPT? And somehow it consider, let me check, consider the upper one should be orange. Well, same as what I'm thinking. The color 2 somehow is that it should be green. Okay? So maybe it got its own logic. You can just try to follow its logic. Okay, but actually seems not the same as what I'm thinking. One more. Okay, another types of IQ tests. This is a magic addition, not the conventional additions, right? So 2 plus 7, it can give 63, not 9. 3 plus 2 can give 10, but not 5. 4 plus 8 give 96, okay, but not 12, and so on and so forth. Okay, then the question is 9 plus 5. Okay, this magic plus, magic additions. What should be the answer? I give you some time to think about it. Okay, time's up. Okay, so the magic formula actually works like this. Okay, the first number add the second numbers. Okay, for example, 2 plus 7 give you 9. Then for this answer, I try to multiply this to the second number. 9 times 7, okay, give you 63. Okay, let's try the second one. 3 plus 2 give you 5. 5 times the second number 2 give you 10. Okay, you can check with the remaining 2. So using this magic formula, this magic additions. So 9 plus 5 give you 14. 14 times 5 give you 70. Okay. So according to my version, the correct answer should be 70. I keep saying questions to ChatGPT, and the answer is that I don't know how to figure out the formula, and I don't know the answer. So that's from ChatGPT. So, is ChatGPT intelligent? For the first question, okay, good. Second one, not too sure. Third one, like this one, it basically cannot figure out the answer. But then you may ask me, so what do you mean by intelligence? Okay, able to answer all the IQ tests. Should we consider that to be intelligence, or is that sufficient? In fact, there's no consensus regarding the definition of intelligence. Okay. Even though I may not be very good at mathematics, sometimes people can consider me to be intelligent in some way. So someone say if you got abstract reasonings, possess some kind of intelligence. If you can understand some complicated theories, skill, possess some intelligence. If you can learn effectively, intelligent. Can solve some problems and plan it properly, intelligence. Wow, this one is complicated. Self-consciousness. If you can know your own existence and reflect on that, of course, it's only intelligent being can do that. Okay? Can computer know its own existence in a manner that we understand? It's a very complicated questions. Communications, if a system can communicate effectively with us, then we'll say it's quite intelligent system. But anyway, so that didn't saying, but so far there's no consensus. It's very hard to have the definitions of that. Let's we have warmed up a little bit regarding the topics or the term intelligence. Okay? Now we focus on artificial intelligence, AI. Okay? So when did AI get started? Actually, right after the very first digital computer was invented. That's called ENIAC 1945. Okay, so what is digital computer? So it's machines, right, that can do a lot of calculations very, very quickly. Okay, and then a lot amount. Okay. Then once people invent digital computer, and once they notice the how powerful it can be, then the next question is there a limit? We human beings cannot do a lot of calculations within a second, but this digital computer can. Is there a limit? Can these machines behave like human beings, like how we think? And can it solve problems like human? So AI is not a new topic. So when the digital computer was first invented, very soon people start to think about these questions. Alan Turing, people also call him the founders of AI. He invented digital computer, and also afterwards try to think about these questions. Can machines think? And after studying this question for some time, you think this is too hard a questions to ask. So instead of getting an answer for this question, he modified the question a bit. In the sense that he proposed a test. So if our machines can pass this test, then it consider these machines to be intelligent. Because whether machines can think is very hard to be defined. But whether it can pass the test or not, could be easier to be defined. So the task is like this. If machines can imitate intelligent behavior equivalent to persons, or in a way that is very hard to distinguish from a group of persons, and you consider these machines to pass the Turing test, you consider these machines to possess some intelligence. Look at the slide, look at the picture, and Alan Turing can come up with this thought experiment. He called it imitation game. You can search through the internet. Actually, there's a movie produced in 2014. Okay, the name is Imitation Game. It's about the backgrounds of this development. So look at the picture. You see A, B, and C. Suppose you are the person C. Okay, you are in front of a black curtain. At the back of the black curtains, there is a computer A, and also there's a person B. Okay, and C, that is you. You can communicate with A or B without knowing whether it's a computer or a blue persons. And the exchange is through electronic text. Okay, if after some periods of communications, if C, that is you, cannot distinguish whether Z is a real person, A is a real person, or B is a real person, then A passed the Turing test. That is, C cannot distinguish, okay, whether A is a real person or not a real person. Okay? And that's why A properly imitate the communications behaviors of real persons and trust it pass the Turing test. Okay, if machines can pass this test, okay, based on Turing suggestions, then we can consider this machine to be intelligent. I hope they can get the point. So you can go to this YouTube, and this is modernized versions of Turing tests. Okay, that was put forward in the more recent movies. Alan Turing did not use the term artificial intelligence. He invented digital computer and would like to study whether machines like this actually can think, and then propose the Turing test. Okay. Not many years afterwards, so John McCarthy, he is a professor at MIT, first coined the term called artificial intelligence, that is the AI that we're talking about today. Look at this, it's 1956. So AI is not a new area. At that time, John McCarthy defined this to be a field about science and engineering, making intelligent machines that can understand, they can think, they can learn, they can behave like humans. Okay, and nowadays we know that we are not just confining ourselves to science and engineering. AI can be used in creative arts. AI can be used in healthcare. AI can be used in business, and so on and so forth. Okay, but in the early days, it's supposed and thought to be only related to science and engineering. And what John McAfee put forward, the term AI is more like visions. Building intelligent machines, okay, that can understand, think, learn, behave. Good. Okay, but what exactly do we need to do is very high level. Okay, the contribution of another professor from MIT, Marvin Minsky, he presented some specific AI tasks. Okay, try and ask people to focus to develop system. Okay, that can manage or that can carry out those tasks. Okay, that was around 4 years after the term AI was first coined. Okay, what are those specific AI tasks? The first one, very often we call it AI search. Basically, it's very efficient search from some structured knowledge or large amounts of knowledge. We can do that, right? We learn a lot about a particular area, for example, mathematics, right? Or history, okay? And then people ask you the question, then you can quickly search from this structured knowledge and then find the answer and give out the answers, right? And very often that involves some logical reasonings. If you can do that very efficiently and can solve the problem, then they consider to be a specific task. Ask people, and Minsky wants some people to focus on that. Another thing is Sometimes it's not just solving one problem. Sometimes the problem is just too complex. It needs to be first decomposed into some smaller problems. We call it sub-problems. Okay? And then you can solve it systematically, step by step. For instance, if I want to ask a robot to move from my office, okay, automatically, autonomously, okay, and go all the way to, say, Festival Walk to buy me a cup of coffee. Of course, if this robot is intelligent enough, probably has to decompose this navigation task into first, okay, go out of my office and then go to take the elevator, go several levels down, okay, and then go straight ahead and then turn right, turn left, and then cross the road and watch the traffic light and all the way go to Festival Walk, go to that shop, buy the coffee, and then get a coffee for me and go all the way back. It's a plan, right? You have to solve each of this, going out, taking elevators, cross the roads, or some tasks, okay? And if you can do the task step by step, then you can finish the whole complex problem. So can be a cup of coffee. So this people call this kind of problems or AI task planning. And the third one, I think all of you are very familiar with that, so it's learning. Learn from past experience. Right? In these days, past experience are digitally archived. Right? So we have the data, our old emails, our old conversation with friends. Okay, try to learn from those data, past experience, so that then you can build some intelligent machines. Okay, I don't think I need further explanations of this. So the following slide, okay, try to project some milestones related to the developments of AI. Okay, as I mentioned before, AI, this term was first coined in 1956. But before that, even though before digital computer was invented, people have been interested in imagining there are some artificial life, there are some handmade objects, okay, which somehow can move by itself, as if, okay, it can sense the environments, as if it can do the action by itself. Okay, Talo is probably one of the earliest graphics, kind of a fraction in the old day. Okay, so hundreds of years before Christ. Okay, that Talo basically is inside a story. There is a giant, okay, made of bronze, and it can the mission is to protect the island, okay, and move around, okay, so and so forth. And then people come up with this idea after thousands of years, okay. I should say around, okay, by 1774, okay, and then from a horrible monster, okay, compared to they call it artificial life, this kind of a toy, they call it automata. Okay, they can, for this one, you can try to play the harpsichord, okay. And so after birth of AI, okay, we see that some more milestones achieved. Robotics, okay, Asimo from Honda, Deep Blue from IBM, okay, that can beat the world champions of the chess. IBM Watson, again, can win the world champions of a TV quiz show, okay, Jeopardy. Self-driving car, I don't think I have to explain more. All the major car manufacturers are producing, okay, the self-driving cars. AlphaGo, okay, a system from Google that can win the world champions of the chess game Go, which is considered to be the most complicated chess game in the world. We talk to Siri. Siri understands what we're talking about and then give us whatever information we needed. Okay, similar products from Amazon is called Alexis, and Google also invented AlphaFlow, which help the scientists to understand, to unfold actually the structures of protein, which is considered to be very, very hard for many years. And 2 years ago, okay, a bit more than 2 years, ChatGPT, okay, that we're using every single day, it seems that it's capable to answer most of our questions. Okay, so you see the spectrum, historical developments, and different milestones, starting from imagination to something real we can use in these days. Over the years of developments, okay, there are 3 boom, and we are in a boom 3. First boom, okay, is very start of different AI technologies, okay, AI concepts, okay, GOFAI, okay, and people use this acronym to mean good old-fashioned AI. Okay, people were amazed by the possibility to have intelligent system. And boom 2, they call it expert systems. Basically, people try to store many rules, okay, into the computers. Say medical doctors, okay, they can do diagnosis because they can remember lots of rules, okay, about health, about anatomies of our bodies, okay, about different symptoms, okay. If we can store all the rules in the computer and build what they call at that time expert system, okay, or not just for healthcare, but also for some other areas, developing expert system of different areas. Maybe that would be very useful. Okay, so that the second boom, a lot of money, a lot of people think is well investing the money. And nowadays we're in boom 3, machine learning, deep learning, autonomous vehicles, self-driving car. Okay, is so familiar to us these days, right? And in particular, you see this term being put here, AI for social good. In the old days, like boom 1 and boom 2, the AIs are still considered to be confined into a specific application or a specific small groups of people. And in these days, okay, boom 3, AIs has been applied in different sectors, has been penetrated to different sectors of our life. Okay, so the influence will be large, right? Will be very influential. Okay, will actually affect a lot the life of a lot of people. Okay? So it becomes so important for AI to be developed for social good, developed to how building a sustainable society. So that's one of the motivation why we developed this course. Okay, how important in fields of computing, to the extent that 2018, okay, these 3 gentlemen, they are the key persons behind machine learnings, okay, so AI. From left to right is Hinton, okay, and then Bengio, and then Nakun, okay. They received the ACM, okay, Turing Award, okay. Remember, not Turing test, okay. Turing Award, okay, which is kind of equivalent to Nobel Prize in the science and the other subjects. Okay, so I've finished a little bit the key milestone developments in AI. Okay, up to the point that AI has been considered very, very important, not only in the fields of computing, okay, but different sectors. Okay. So in these days, we can try to understand an AI system from the perspective of this framework, sense, think, together with act. So most of AI actually involve these 3 components. With these 3 components, we actually not just call this AI system. Sometimes people call this kind of AI system an intelligent agent that can use a sensor to sense, to perceive the environment. Okay, with all the data sensed and transferred into the agent, the system, computer, machines, whatever you call. Okay, then you can do some analysis. Okay, just like thinking process in a human being. So that's why the second step is think, sense, think, and afterwards, right? You make some analysis. You probably would like to do something in response to, okay, to what you can sense, okay, after some analysis, okay, to achieve some goal. Let's take some examples. Sensing what should be sensed. Okay, if you sense, say, text, basically you want to understand some natural language. Okay, so this field is called natural language processing. Input some text and try to see meanings. What's the meanings that? And then, or audio signal, audio sound. Okay, when I'm talking, actually, you see actually there's some audio waveform, audio signal going all the way to the microphone. Okay, so that you can hear my voice. Okay, but then how to analyze this audio signal? Okay, so as to become words, so that you can understand. Of course, that happens in your brain, in your ear. Okay, for computer or for AI system, that field is called signal processing. Okay, and now and also, okay, there are some technologies that can understand objects in the image, in the video. Okay, that is called computer visions. Use camera to sense the environments, okay, analyze the image and the videos accordingly. And also we have other type of smart sensor. Okay, it's just like a smartwatch, which can sense our heartbeat. It can sense our other vital sign, and so on and so forth. Okay, so with all this smart sensor, okay, the data of the environment in different formats can go to the brain. Okay, to the computers, and computer can do some thinking. Thinking is then do some analysis, do some learning, do some planning, and then represent the knowledge, and so on and so forth, or apply some knowledge. So these topics will be explained in some of the lectures. Okay. So after the thinking process, of course, you have to make some response. Sometimes give out an answer or a reply through a chatbot, or you're controlling a robot, and then robot can jump, can move around appropriately in response to the what being sensed in the environment. And then recommendations, you can also recommend based on what are the available restaurant in this area, okay, and understanding your interests, understanding what you have been talking about in social media. Okay, maybe the system can recommend you some restaurant, recommend you some cuisine, recommend you some recipe, friend, news, and so forth. Okay. An example of Sense+Think Act. Okay, let me play this video for a little while for you, so as to know what I'm talking about. So this is interesting. Two chatbots talk to each other.
Hi.
How are you?
Great. You?
I'm okay.
That's good.
Are you good?
Yes, I am good. I just said I was.
No, you didn't. I said I was.
So you are a robot?
No, my name is Clever.
So if you did watch this video, you probably noticed that these two chatbots were not very clever. Okay, the chatbot in these days are much more powerful. But anyway, in order for these two chatbots, in order to communicate, okay, so each of the chatbot have to first sense what the other chatbot speak, right? Basically, the sound will come from the speaker of the other chatbot, can go all the way to your microphone. Then you pick up the sound, can sense the sound, okay, can sense the audio signal, and then change it to some text, right? Basically tell how are you? Okay. And then based on this thinking, okay, it actually moves to the thinking process. Okay, you can convert the speech to text, okay, and understand the text, and okay, generate a reply. Then move to the step of act. Okay, from this reply, you have to convert it to a speech, and the speech go to the speaker, and speaker say it out, and this kind of audio signal, okay, will go back to the other chatbot, and the communications can continue. Another interesting applications of this Sense+Think Act frameworks, okay, in the context of smart robot. These smart robots can dance, can do group dance. If you close your eye, you want to dance, basically you can listen to the music and then can move the arms, move the legs, move the body accordingly, right? If you, and according to the beats of the music, and so on and so forth. If you understand the story behind, you can do even better dance, right? But you know that if you close your eye, you will be very dangerous because you will collide to some other people around. Okay, so the robot not only need the microphone to listen to the music, also a camera to look at the objects around. Try not to collide into those objects or the other robots, right? So these are the sensing part. And with all this camera and sense, look at the environments, and then the bits of the music going to the computer, okay, and robot has to sing, okay. So how to dance accordingly, and afterwards, then you have to control different joints of the necks, okay, and neck, and each of this robot got neck with them as well. So they can keep balance, move around, dance. Okay, you can watch that movie. Pretty interesting. So other than the sensor that I mentioned, there are also some more complicated sensors. Okay, so building a sensor work like our eyes, easy. Building a sensor work like our ears, also easy, right? Just microphone. How about nose? Do we have electronic nose? How about tongue? Do we have electronic tongue that can taste? Okay. In order to answer this question, in order to develop this electronic nose, we probably, or people actually first try to understand how human sense different smell. Okay. So we can smell, okay, basically because different smell, different scent, okay, it comes from different compositions of molecules, okay, small structures in the air, very very small. Okay, we call in the context of smelling, they are just odorant molecules. Different composition of this odorant molecule go inside your nose, okay, and then your sensory nerve endings can see this kind of structures to that extent. To see this kind of structures, I mean the odorant molecules, okay, their combinations, okay, then then the signal go to your brain, and your brain say, yeah, it smells of coffee. It smells of flowers. It's the smell of a fish. So electronic nose basically adopt based on this understandings of how our nose work, come up with chemical sensor that can sense the structures of the molecules of different chemicals. Okay, and this molecule basically represent different smell. Okay, for more details you can follow this link. And self-driving car, okay, it's also common in this day. There are also other sensors like GPS, which I don't think I need more explanations. Sensor scanner, okay, that can sense the environment, not through camera, but through sensor. So that in front of me, if the distance from the car to some obstacle in front of me is very short, laser sensor scanner basically can calculate that, can estimate that. Okay, not just in front of me, but surrounding. Okay, and inertia measurement units. Okay, it can try to measure the orientations. Okay, orientation of the car. It make use of gyroscope and also how fast the speed is increasing. Okay, accelerometers. Right, it's important to control the speed of a car for safety reasons. Right, camera, no need to explain. The wheel encoders. Sometimes when the road is moving, whether the car is moving or not, okay, as what we expected. Okay, wheel encoders basically can help us to observe how well the wheels is behaving. Okay, so sense, we have spent some time to talk about sensing. Okay, for act, okay, we probably won't touch on it in today's lecture. Okay, and then how about think? Think also in some of the lectures. But before we move to the other lectures, it's important, okay, to let you know there are two major AI. Okay, so we understand AI vision, we understand sense, think, act. Okay, it's high level, just concept. How can we design some computer programs, okay, that can, accomplish those AI tasks, okay, as what we wish? Of course, there are more than one way, okay, to finish a task, okay. And out of all these methods, there are basically two major approaches. One is called symbolic AI. The other one is called connectionist AI, basically. Okay. So symbolic AI, from the name, probably you can understand, it makes use of a lot of symbol that we human beings can understand. Okay. Let's take this example. Okay. By looking at the green box, probably it's not that hard to interpret. To interpret means look at this and you see the meanings. Okay. So this rule is vertebrae X. X is considered this to be some kind of objects. Okay. So if this object X is a vertebrae, vertebrae is the animal, okay, with the spine. So if this is a vertebrae, okay, this object A is a vertebrae, then this object X must be an animal as well, right? Easy. And then, so look at the green, second rules is vertebrates. Now, these symbols correspond to N. Has fur is vertebrae, and at the same time, has fur is basically a mammal. Okay? If you have studied biology before, this is a knowledge from the animal classifications, and we can have a lot more rules like this. Okay? All these rules can be understood. Okay? All these rules can be interpreted. Okay? If you take this approach, which we call symbolic AI, versus, okay, the other one is called connectionist AI, which is kind of more modern these days. You see that X, Y, W, B, F, X, okay. Very hard to interpret, right? If I don't further explain that to you, you don't know how to interpret what are the meanings of all these, okay? And that's so difficult to understand, so why do we need to study it? In these days, the most powerful AI machines like ChatGPT make use of deep learning, and deep learning is falling under this approach, connectionist AI. Okay, it's very powerful, so that's why we still have to learn about that. So this slide actually try to summarize a bit what I have just explained to you. Symbolic AI actually was studied a lot in the old days. Connectionist AI are considered to be more modern, okay, relatively speaking. Symbolic AI, you see the two ticks, right? It's interpretable, that is, look at the rules, I can see the meanings. I can explain to you the meanings of the rule. Okay. And because I can explain, the second tick, let's say, easy to control. In what it means is that if this is incorrect, if this rule is incorrect, because I can explain, so I can also correct it, right? If some rules is not correct, I can simply remove it. Okay, it depends on situations, right? So this is what we mean by easier to control. It won't go out of control. Versus for connectionist AI, you see the two clauses. Okay, connectionist AI is considered to be a black box. Hard to explain. Hard to explain, so that is something wrong. Also hard to modify, hard to edit, hard to remove. Okay, so that's what we mean by hard to control. Okay, but again, as I say, Advantage, performance very good, and also there's no need to write program. Just learn from big data. IBM Deep Blue, the machines that win the world champions of chat, use symbolic AI. And all those more modern AI system, ChatGPT, AlphaGo, so on and so forth, they all use connectionist AI approach. To conclude, today's AI, people will say, we are quite successful regarding artificial narrow intelligence applications. So most of these applications focus on one specific task, like, okay, we can build a fingerprint recognition system. We can build a chess playing system. We can build a stock prediction system. So one system for a specific task. Artificial general intelligence, an AI system that can do many things, many tasks like a human being, general. Okay, ChatGPT seems to be very first step towards this kind of vision. So this is today's situations. How about future? Who drives the future? It's very hard to know the futures, right? Who can tell the futures? So that's why we ask the next question. Who drives the future? My answer is you all will drive the future, right? After several years of studies, then you will start your career developments, and after some time, you take up some important position in different company. I do believe that AI will be everywhere in every company deployed, used, developed throughout the years to come. So you are the one who will drive the future. Okay, that's why it is very, very important that we hope all of you, should think carefully. How should we drive it? Okay, not how should we use it at this moment, which is of course interesting, but you should know. We all expect you all to know how should we drive it. How should we drive its development for social good, for sustainability of society? Okay, and really the last slide. Remember this: AI actually is not only related to computer science or mathematics that you may have that in mind, but it's also related to biology, neuroscience, sociology, psychology, philosophy, linguistics. So if you don't believe that, you can send me email. We can have some chats based on that. With this, that's the end of the lectures on AI, history, and future.